Hello viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about space launch market update. What the hell is happening on the market money front? So let's dive deep into it. So first you have to understand there are some what we call milestone event, like for example a Sony Walkman. Like there was a world before Walkman and there is a world after Walkman. Same way there is a world before iPhone and after iPhone. Same thing is post SpaceX era, meaning after Falcon 9. Falcon 9 is the what you call iPhone event. Before Falcon 9 and after Falcon 9. We are in after Falcon 9. So what does it mean? Like what did it change? Well, the biggest thing it changed, be mindful, it's a private company. There were many private company. It's just that private company can make a cost competitive rocket that can deliver without a defense money. Meaning why ULA was created. They were getting $1 billion annually. Like $1 billion, go. Why? Just so you can stay in the game. Just so when defense contractors need to actually launch a satellite, you have something. That's how bad it was. So going from that ecosystem to like, no, there is a company that's completely self-sufficient. We just have to pick up a phone and it's like, hey, can you prioritize us? That's it. So that was a big jump. And be mindful, there was ULA, there is Arianespace, there is Northrop Grumman, and all of these companies after SpaceX, Falcon 9 specifically, looks like they never ever upgraded after Cold War. And that's half actually true, because during basically Cold War era, money was flowing like, don't count it, just make something cool. People were going YOLO on it, and a lot of technological development was happening very quickly. Basically, we went from V2 to Saturn V surprisingly quickly. But here's the deal. Once people realized that Soviet Union is already kaput and they're not actually going to do anything, specifically after basically Saturn V proper lunar landings, yeah, people are like, yep, there is no more interest. So money taps started to close down. There was some rockets designs that were like almost ready, like I think RS-25 was like almost finalizing at that point in time. Those continued, but after that no single engine was designed from scratch. Most were like, okay, we were working on this, let's finish it. It was more that. And SpaceX showed that. It's like, what if, hear me out, what if we started from 2005 technology? Not 1975, 2005. So that was a big deal. That's what changed. That, hey, wait a minute, none of you ever bothered to design a new engine from start. So you are a relic, you are a money waster, and you're slow. So that became an absolute reality. And the best demonstration of that is, this is Soyuz. This is from Soviet Union. It's still being flown. It's a washing machine with people inside. Like you can see, that's it. Now here's the, China did it. China must have upgraded it. They took that. This is what it is. It's almost like a phone booth size. So they scaled it up. You can still say still not that comfortable. And SpaceX, yeah, we designed it for almost space shuttle replacement. So it has 8 people capacity. The idea with that was that if you can only have to handle like 3 hours of rocket flight, you can comfortably put, let's say, 8 people inside it, or even like 7 people without too much hassle. But if you have to stay there for long in the capsule, because again, capsule reaches the orbit very quickly. It's just that docking process could take few hours to maybe even a day if you are checking or verifying things. Then like, okay, let's scale it down to 4. These 4 people versus these 3 people. Which one do you think have more room? These 4 people have more room than these 3 people. That's the whole point. They took that, scaled it up. This is a fresh design, as in like, what if we design via the technology of 2010? This was started with Dragon Capsule 2010 era. So, and NASA, ironically, one of the best things that could have happened to NASA was space shuttle failure. After that, they realized 2 core important things. First, they cannot be trusted. Second, they must have what we call dissimilar redundancy, as in you cannot have one vehicle anymore. You must have 2. Even if one is expensive, one is cheap, you will still maintain both of them. So just in case if something oops happens, you does not kaput the whole space ring. Basically, you should not be able to clip America's wing again. So that's why they gave money to 2 players, which was SpaceX and Boeing. Boeing still has not delivered it, and SpaceX has made it routine. So basically they went from Russia, could you please carry our astronaut, to we got this, fam, we got this, we are comfortable, we good, we can send 4, you can still send 3, we can send 4, we got this. And China, again, I am hearing that they are designing a newer capsule that is bigger, beefier, and more like 2010 technology, but let's see. So this is why I said, like, there is a before SpaceX and there is a after SpaceX. So this is a big change. Like, While yes, Roscosmos is still being flying like, but yeah, they never upgraded, they never changed, nothing changed. Be mindful. The Soyuz capsule got digital electronics very recently, like after 2000s. So that's the whole thing. Modern crew capsule. Now, in the market, the size went through a lot of trends. For example, in 2010 to 2020, that zone, there was a flood, and I'm pretty sure if you are following rocket companies at that point in time, you must have seen like things change. What changed actually? Miniaturization of electronic became a thing. In 1990s, electronics started to become digital, and by 2000s, it became a useful thing on land. By 2010, it became something that people can actually send via CubeSat in space, and it was doing things. And it became a useful tool. Now that created a flurry of activity where people are like, hey, let's make a rocket that is only for those puppies, as in Virgin Orbit, Astra Space, One Space. There were many more. And one of the big puppies were, which you know, is Rocket Lab at the same time. Now Rocket Lab became champion, almost everybody else went kaput. Now, why? And be mindful, at the same time, 2010 to 2020, a lot of Indian players also got into it, as in like Indian companies that want to make rockets. If you watch my old videos, as in like ancient video, I used to have hair back then. Yeah, many of them created a company, and almost none of them have reached orbit yet. That's why I don't cover them regularly. I'm waiting for any one of them to reach orbit. Few of them are still there. Only one or two of them have changed their portfolio, so to say. They are, instead of making the rocket, they are like, okay, now we're gonna make in-space propulsion. So what happened from that point onwards? Well, mathematics change, and you must have seen this with your mobile phone. There was a brick phone in like early mobile phone era, brick phone. Then we started to miniaturize it, like Nokia, we started to miniaturize it. But here's the phone started to become big again. What the hell? This is a common trend that happens in electronics. First you shrink it, and then you're like, wait a minute, if I can do so like this much task in this much, what if I make it this much again and do more task? There are certain things in physics that always loves larger volume, meaning battery, larger, better, the end. Solar panel, larger, better, the end. Telescope, larger, better, the end. Synthetic aperture radar, larger, better. So that's why CubeSat was a peak term. But if you look at CubeSats that are launched today, most of them are not CubeSat. Most of them are like 3U, some are 6U, some are 9U, some are like, dude, why are you even measuring it in U? It's a freaking huge satellite. It's like this big. It's almost like a traditional satellite. But again, it's far more capable than analog satellite we used to have, but it's big now. So that desire of having like, tiny rockets, it's no longer that attractive. Now again, people still make CubeSats, but those are now testing, and you can see that with Starlink. First Starlink satellite, small puppies. Then like, okay, let's make it a bit bigger. Now they're like, what if we make it huge? What if we make it huge? So it happens. It's always the same thing. Mobile phone is the best example. We had huge phones, tiny phone, then now huge phone again. Same thing is happening with satellite. Satellite went through that shrinking era. Now we still make small satellites, but those are extra, like college projects, testing of some technologies, those sort of things. Not for like, okay, because again, physics does not like tiny microscopes. They're like, bruh, put a big lens, always better. So math has shifted back to big satellites. So, and ride sharing reduced the margin that they had. The idea was big rockets will take too long and all that. So they're like, okay, what if we launch 20 of you in one go, 100 of you in one go, 150 in one go? Yeah, that equation changes the game. For example, if let's say Astra or even Rocket Lab, they will give you some launch price. SpaceX can just divide that by 10 or 15. At that point in time, the launch cost, and that's the whole essence of CubeSats. CubeSats are cheap. Launch is expensive. So if you can launch 2 or 3 satellites for the price of one dedicated launch, it's not a mathematical discussion anymore. So rideshare reduced the advantage. The wiggle room these small rocket launchers had shrunk. On top of that, development of micro thrusters and ion engines. They almost like reached a point where it's like, yeah, just put it on this and you will slowly crawl up to your desired orbit. And because money saving is so big, you can crawl up to like send 2 or 3 satellites and get more work done. So that's why size market has changed. And you can see that in almost all companies. Either they are making big rockets or they're making very big rockets. For example, Starship, huge. For example, New Glenn, they're already big and they're like, okay, now we're gonna make a 9x by 4x because it's gonna be huge. And you look into Rocket Lab, the only small satellite that is like, continuously working, they're like, yeah, it is too small, let's make a Neutron, that's going to be bigger. I'm pretty sure they're gonna name the model after that Atom. That's the only thing that's larger. So Electron, they started with that. They learned everything and they're gonna make two big one. Now be mindful, ironically, SpaceX was the first company that did that. They launched with Falcon 1. They boomed it 3 times, fourth time it worked, and there was no fifth time. They deleted the whole rocket and they directly went into Falcon 9. There was a Falcon 5, but they were like, yeah, small rockets do not make mathematical sense. In this regard, I have to say that company was smart. I have to say this was a very smart move. Do not make small rockets. Economically, they do not make sense anymore. And again, the market has already changed. Most of these companies have already went bankrupt. So that's the size point. We went through that shrinking of the technology era. Now we are expanding era. So you need a big ass rocket. Now we come to the rocket itself, the booster. Now booster is the most expensive part of any rocket. Does not matter which rocket you're talking about. 99.99% of the time, the booster would be the most expensive part. Basically, if there's a two-stage rocket, booster is the expensive puppy. And booster recovery, ironically, has economical advantage, as in it's the economical goal. Why? Because you may think, okay, let's just say it's a $10 million rocket. What if you recover the booster? You should be able to save, let's say 5 million. Now you will save 7. It's why? Because again, most of the engine is in the booster. Most of the fuel tank, as in the lithium aluminum alloy, is in the booster. So if you recover the booster, most of the things are captured. So fundamentally, and Falcon 9 is a very critical thing. Be mindful, there were companies that were trying to do propulsive landing before Falcon 9, but none of them ever got to that stage. So Falcon 9 made it routine. What does that mean? It's the Manhattan Project. Before the original boom of Manhattan Project, people were discussing this. They were chasing it, but they were discussing it. It's like, would it work? Like, let's see. And after Manhattan Project, it was done. Like once you showed that it can be done, it's only a matter of time before everybody else figures it out. And you can notice that in today's market, any new company that is coming into the market, they are always day one. They're like, yeah, we're gonna have a booster reuse. Like Honda is like, they're not even making a rocket yet. They're just demonstrating. What's the first thing they did? Propulsively landing. So they are doing it, everybody is doing it, and it will become common. For example, New Glenn only launched 3 times. When I'm making this video, they have launched 3 times, only had 1 payload deployment failure, and 2 times they successfully landed the booster. And be mindful, this is the 3 grand total launches. That's a random, like, oh, we figured out how SpaceX did it. And it will happen. I can guarantee you the companies that are coming afterwards, they're like, okay, we're gonna land it. I'm pretty sure Neutron will also figure it out very soon. Maybe 3 launches, maybe 5 launches. They'll be like, bro, we done. We know how this works. We have seen it again. So it's like, it will be done. And what about it? How do you land? Well, you have landing legs. That's one stable option. There are other options like chopsticks, net. China is trying to capture in nets. Not even nets, like almost bungee cords, but I've not seen deployment of yet. I've seen the physical structure, but not the deployment. So let's see what happens with that. Landing legs is a stable method, but you get 2 options if you have landing legs. First option is ship landing, as in you have a ship, you land there. That's flexible. From a rocket point of view, that's far more flexible to have. Come back to land, for example, this, or basically super heavy booster that has to come back to land. Because again, there is no chopstick in the middle of the sea, and I don't think they have put a rocket booster legs in order to land on the ship. So land is cheaper. So you have 2 balancing vectors. One gives you flexibility, another gives you cost effectiveness. You have to balance it out. And most likely, if things go normally, knock on wood, by 2030s, it will be boring. Nobody would watch it. And again, nobody is watching even basically Falcon 9 landing. And again, most people are complaining that this puppy, 3rd try only, by the way, this is the brand new rocket, this is the 3rd try. Nobody was impressed by, oh, you landed the rocket. Be mindful, this is the only company that has landed a booster that has actually deployed anything in space other than SpaceX. Nobody has done it yet. They're the only one who did it. And people are like, bro, you have to do better. I'm like, they should. Because, and again, that's what we wish for. By 2030, it should be normal. It should not even, you should not require to think about it. Now, what about second stage? Well, second stage has some problem. Like you are looking at like 7,000 to 8,000 kilometers per hour, give or take in that zone with when you're talking about booster. When you're talking about second stage, you're talking about 28,000 kilometers per hour. That's bonkersly fast. So that makes recovery hard. Not impossible, hard. But the closest thing we have that actually did recovery is Space Shuttle. Because again, it went to full-fledged orbit, landed from full-fledged orbit to a normal system. Now be mindful, Space Shuttle is very close to single stage to orbit because The shuttle starts firing its engine when it's sea level and keeps firing it until it reaches to orbit. It's like parallel staging. Now there were designs where they would have a booster stage, and then this was made into two variants, one cargo variant, one crew variant, and instead of empty space in the back, which was the cargo variant, it would be like fuel tank would be there. And because it would be pushed rather than going YOLO from sea level, it could have managed to like go to orbit and all that. Size would have changed a bit, but it was possible to design a space shuttle that can actually, that will be the second stage that is fully reusable. So it proved the concept that you can send engines to basically orbit, bring them back and ready to go. That's why I'm not counting capsules. Capsules don't have engines. This puppy carried the engines and brought them back and reused it. So space shuttle is the only working model. Now, there are other options. For example, fairings. Now, fairings are still expensive, and any amount of money you recover is the money that you do not have to spend. Now, fairing recovery, you must have seen all the hassle that happened. It's like, what if we had a net and then like, okay, that ship is costing more. Just land it into the salty water, and because it's made out of composite material, it's not gonna corrode very quickly. They landed it, it's like, yeah, it's fine enough, and they're like, okay, let's just do it. It's so boring that we did not even pay attention to that. That New Glenn also does that. They already did it. There are photos of it, like they had it captured, and it's like, nobody pays attention to that. That's good. That means it's become boring. Now, propulsively landing the second stage. Yeah, that has a problem. That consumes a lot of payload fraction. And you are getting paid for the payload. So if you can launch something, let's say 150 ton to orbit versus 100 ton to orbit, but you reuse the second part, it may not be as cut and dry as you might think. So payload fraction is a big deal. So this is the part that people have to sort. Can we land the second stage? Yes. What are our options? Well, one of the unique option is inflatable heat shield. I have talked with a rocket company and they are trying to do this inflatable heat shield. The essence with that is the mass penalty that they have is much more. First, they have a second stage, do a deorbit burn. By the way, that's law. All rocket second stage should do that, because if second stage does go to orbital velocity, if it does not do deorbit willingly and knowingly, it will still be stuck in the orbit. So for that reason, it is necessary that all second stage must have the ability to do a deorbit burn. So what if you do the deorbiting burn anyway? Cool, but you have a inflatable heat shield. So it's a small thing, it expands and voila, you land it into the sea and you capture it, recover it from that. Now, main issue would be how the heck you manage the corrosive water. But if you can manage that, it should be doable. Physics is sorted. Be mindful, this is NASA's actual testing of a basically re-entry inflatable heat shield. They actually made it, actually flown it, tested it, it's done, it's good. Science is sorted. Engineering, we have to figure out like how to optimize it and all that, like how do you encapsulate the rocket engines, but it's done, it's doable. And New Glenn also has a patent of a aerospike kind of engine that should allow them to do that. This is another company that is trying to do second stage reuse. Again, they will have much smaller payload fraction because it will have to conserve a lot of fuel in order to do propulsive landing. But again, if the rocket becomes cheap enough, it might be acceptable. Balance, trade-off. So this will be the next evolution, meaning what rocket engineers are working on right now, not booster reuse. If you are having trouble with booster reuse, it's a mechanical problem, as in like, oh, this part did not work, like PID loop was not tight enough, like we done, like even China had done multiple landings and again, not from orbit, but they have like, you know, safely landed in the water. That happened very recently, safely landed next to the land, and then they had like almost landed, but it's like, it will be done. Like by 2030, it will be done. So that's on engineering team right now. What are scientists working on? Scientists are working on how the heck you solve the second stage. Would you use inflatable heat shield? Will you utilize a propulsive landing? How do you maximize the payload to orbit while having a reusability with flexibility? So that's the market race right now in technological term. Booster, almost everybody is like, this company is not even showing how the heck they're gonna do booster recovery. Their day one, this is our second stage recovery. We have a stainless steel heat shield that is being actively cooled by liquid hydrogen, and that's what they were demonstrating. Now we come to the big daddies, which is space race. Thankfully, like same way we had massive technological development during Cold War and Soviet Union versus USA, we are having the same thing, USA versus China. But market has changed, meaning this time we want it to be better, meaning it's no longer wartime kind of scenario. So neither party wants to risk blood anymore. It's like, no, you have to come back alive. Like, we're gonna send you, but you should come back alive. So that's the better part. But both parties are conserving their money. This is the one thing that China learned very well from American Apollo program. It's like, yeah, you cannot run a program like that. It will drain a country's economy. So it has to be cheaper. So not only better, but it has to be cheaper. Now, what does that mean for you and I? It simply means world wants to do space as a side quest. For example, what is the most profitable thing in space? Private satellite constellations. That's what's making money right now. And this was not today. This is before SpaceX. This is like, what do you think the first printing money was? Dish TVs. They were printing money, like bank kind of money. So that's the whole aim. Aim is space organizations like NASA, ISRO, JAXA, all of these puppies, they will be just a facilitator, lawmakers and all those jazz. Basically, they're gonna be lubrication, not the main fuel. Private enterprise will be the main fuel. So national agency will just utilize service, meaning we need to send this much ton in this much volume into orbit. Go bid. Like for example, if you look into American private fighter jet complements, it's never like, okay, make this. It's always like, we have this requirements, go. So Boeing will make a craft, Lockheed Martin will make F-35, and you're going to have compete with them. It's like, okay, this has this offering, this has this offering, we're going to select this. Again, that's a good thing. That's a desirable thing where you have competition, and competition drives down the cost. That gives you the cheaper part, and because you have dissimilar redundancy, it gives you better learning also. So that's the aim. You do not want NASA to burn money. You do not want China to burn money. And be mindful, even China learned this. That's why I said, like, there was before SpaceX and after SpaceX. Even China is like, it has to go to private as quickly as possible, and they're working their ass off. And money is the final limitation in this era, as in like 2025 era. Money is the limiting factor, not technology. Like, can we send people to Mars? It's a minor inconvenience for us from a humanities point of view. It's just that we can't do that with the budget. So it's the finances that has to matter. Like, for example, can we make spacesuit? Yes. We have to make a spacesuit in $100,000, not $1 billion. That's the issue right now. And again, do we have physics that allow us to shrink that kind of cost? Yes, mass production has done that magic. Like, most people do not realize how big of a magic this is. I am old enough to remember its predecessor. Like, I'm old enough to remember that mobile phone used to advertise that they can store 1,000 number in the phone book. That's how old I am. So let's look at, this is the race that we are going on. Where it's like, okay, do better, do it cheaply, and we're just gonna order things. We're gonna like, hey, I need to send a satellite. This is a satellite volume and tonnage. Compete. And it's like, okay, we have this, like, and of course, they will make sure the cheap one is used most often. But again, they will make sure that sometimes they will use the expensive one. Because again, dissimilar redundancy. Space Shuttle taught that a very hard lesson. And be mindful, if America went with the same mistake of Space Shuttle and only funded Boeing, they would not have the space wing. So this is what they learned the hard way. Must have multiple redundancy. So this was my presentation on basically what's happening economically in space sector. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show my extra disappointment. Please leave a comment because I do try to reply to all of them. If you have liked the video, please click the hype button, press the subscribe button, press the bell icon if you're free. And as always, thanks for watching.